Okay, so welcome to Collaborative Statistics. This is Chapter 6, the normal distribution. And so the normal distribution, what is it? It's a continuous distribution. It is the thing that we're going to focus on for the next 4 chapters. So it's very, very important to statistics. It's a bell-shaped curve, bell curve. You'll see, we'll see it in a couple seconds, but it is something we are going to focus on for pretty much the rest of the semester. So we need to understand it very well and how to use it. As we said, it's a continuous distribution. So we're taking ideas still from last chapter and bringing them into this chapter. So remember, last chapter was about continuous distributions, and we looked at the Poisson and the binomial. We needed to look these things up. So here this is something we're gonna have to look up. It's a symmetrical curve. If it's bell-shaped, it's symmetrical. If we draw a line down the middle of it at the mean, they're exactly folded over. It's exactly the same. The thing that's important to talk about, the spread of this curve will be the standard deviation. Okay, so we could have two normal curves, both of the same mean, in different shapes because of the standard deviation. The standard normal distribution is basically, remember I mentioned standardizing the data. This allows us to bring it down to a specific value. And so we do this, and it gets a mean of 0 and a standard deviation of 1. There's a table that we use to look up all normal curves. This is the standardized normal distribution. Okay, and I will show you that in a second. Oops, wrong way. So here it is. It's a standardized normal z. So it's the z-score is what we're going to be looking up when we have a formula. We looked at it before in like chapter 2, I think we talked about finding a z-score and standard deviation. This allows us to measure how far something is within standard deviations. So the z-score is just how many standard deviations above or below the mean a value is. The standardized normal curve, which is this is the normal curve. This would have a mean of 0 and a standard deviation of 1. So this would be one value. This is 2 and this is 3. -1, -2, -3. See, we multiply by the standard deviations. And the z-scores allow us to compare data, just as we did with chapter 2, where we said, well, gee, did Mary do better than Lucy on her test, where they had both of them had one had a 70 and one had a 75, but the means were different and the standard deviations were different. So we looked to see how much better or how much worse somebody did comparatively, and so this allows us to do that. So again, here's our formula. Z is equal to the value x, whatever x is, minus the mean divided by the standard deviation. And it's built upon the empirical rule. I know we just talked about this in chapter 2 again. Remember, we had Chebchev's, and then we had the empirical rule, the 68, 95, 99.7. This is the rule. So one standard deviation between here and here, 68, and it's really 68.14, but it's close enough to say 68% of the population is here. This is 34%. This is 34%. They're evenly distributed. This is 95% of the data is between here and here. This is where the idea of outliers come from, because that means that this here is only 2.5% and this here is only 2.5% of all data. So that's why we can say that those are unusual, probably not likely to happen randomly. They have to be, just by default. So accidentally, if we find something out in these spaces, there's not a large percentage of those chance of those things happening. 3 standard deviations from here to here is 99.7%. So that's almost everything. And we'll never get all of it because this continues on. It just gets smaller and smaller and smaller and more zeros as we go along. So we very seldom tend to think of anything occurring after 3 standard deviations, and almost nothing occurs after 4 standard deviations. But you can do math and find something that's 17 standard deviations above the mean, and it's it's all zeros for a long time, but there's still a small chance of something being there. So this is what the standard deviation, the standard curve or bell curve, z-score, z-curve all look like. So the big thing that we're going to be doing is trying to figure out how much space is under the curve. And we can find out, what's to the left of a line or what is to the right of a line. Okay, and to do this, it's the same thing. We're probably going to use our calculator, but we have a table. We first draw a curve, find out what our z value, put our mean in. Okay, we find our standard deviation. Then we calculate a value. Here we're looking for this 162. Well, we know it's over here, and we want to know what's the chance of it being less than 162. What is the chance of this being bigger than 177? So we would do those out and find our z values, and then we can look them up on this table here. And this table, we look down and go, okay, well, this one, let's say it was negative 1.6. So we'd go to negative 1.62. Alright, so negative 1.62, we'd come across and we'd say, oh, this is the probability that it's this side. And this is always giving us to the left. If we want to find to the right of something, we subtract the value from 1. And that would give us how much is to the right of it by doing it by hand. We're going to use a calculator. Alright, so here they're asking the probability that something is greater than 145 based on the fact that the mean is 100 and the standard deviation is 15. So we plug those in. So you notice I drew the curve. And what's the probability that's over here? Well, we need to put in our calculator, we have normal CDF. Okay, we go to second distribution. We find normal, I think it's the first one, and it'll put a parenthesis. We put the lower bound, which is 145. The upper bound, which is, a 1 with lots of zeros, or here they put, 9,999. You just want to make sure it's a big number. Okay, what is the mean and what is the standard deviation? And it will find out for you. It will give you this value, 0.0013. Well, now if they want it percent, we have to make sure we write down the answer. So it would be in this case 135%. Okay. If we want to find the next thing here, talks about what value this is a different problem. That doesn't go to this. Very strange. If they want to find between two things, okay, we would just use these two values. So this would be our lower bound, and this would be our upper bound. And this looks like, and it's a normal distribution. The standard normal, so our mean is 0, our standard deviation is 1. If we're doing this, we're trying to find, well, what value is the 60th, is 60% of the data, less than. Well, again, we go to second vars, we bring up this distribution, and we do inverse norm. Okay, and this talks about, this is the percentile formula we're going to see, and we put in our area that's under the curve. So 60% of below what value? What is our mean and what is our standard deviation? And we would get an answer. Okay, and so we're going to see some formulas here. This is how we write the standard distribution. X is represented as the normal curve, parentheses, put the mean and the standard deviation. So make sure you put your numbers down. If it's been normalized, if it's the standard normal probability, then the mean is 0 and the standard deviation is 1. Okay, and notice here they capitalized the z. Okay, so this is the standard or normal curve in this case. Okay. We don't see this one as often, but we will see, you will be writing this one a lot. Okay, that's the difference. I just wanted to show you the difference between the two. This here was the thing where we just did, where we were finding our percent below the curve. Well, if we're trying to find the percentile, below a curve, that percentile is going to give us mean plus their z-score times the standard deviation. as I showed you here, we just use this formula and say, okay, we know our percentile. Here's our mean, here's our standard deviation. We're going to really find out what the z-score of this is, and we would then do that math. But if we were to look on the table here, we could find 60%. Yeah, I can zoom in, yes. 60% is right between these two numbers. So 0.26. Okay, so we would take 0.26, multiply it by our standard deviation, add it to the mean. That would give us the value that is less than that. Okay. In this case here, we just plug it into our calculator, we come up with the value. But that gives us the percentile. So that's formula 3 that they looked at. I don't know why they put them in this order. It seems like a weird thing. And then the z-score, which is what we're usually looking up, is again, z-score is equal to the value that we've been given minus our mean divided by our standard deviation. And so you can kind of see where these two things come from there. We have our k value. We could call this x, I suppose, and then we could see that, yeah, all right, those things work. Multiply by the standard deviation, add the mean. So they work back out. Okay, so that's everything in chapter 6 quickly, and I will see you in class.